I cannot actually see you from the light, so it's much less anxious for me. So wasn't part of the talk. I just want to echo what Martin said, that the social part of all of this is extremely important. I think us as engineers really think that we can fix everything with tech. That unfortunately isn't true, so everything that he says, 100% agree. So it's a strange start to a Monday morning, basically. We need to get a little flipsy and not be anxious about all of these things. But the mental health talk is definitely a good start. So other than battling anxiety, it's generally how to make people less anxious when using Web3. And this will actually be a technological talk, even though it maybe doesn't sound like it. But before we start, as this is the first/second talk of this morning, I want to stand up when I say something for people to stand up. So if you're a multi-signer, so if you have a seat on a multi-sig, please stand up. Good. OK, no, keep standing up. Sorry, yeah. You're going to stand up for the longest. OK, second group of people, you did a swap on any aggregator, whatever, and the price was wildly different from what you wanted to do. Please stand up. Great. OK, a failed transaction that costed you more than like 50 or 60 bucks in ETH. Please stand up. Are we feeling anxious yet? OK, everyone can sit down, and you're going to see why we did this. Other than my speaking coach telling me I need to get people active before we all start. So the agenda for today is we're going to talk about 4 topics. They're by design ambiguous like this, but we're going to talk about a couple of problems that we see before even sending a transaction. The second one being is trying to tackle one of these, and we're going to talk about how you can do this yourself or by using different tools and services. The third one, we're actually going to look at the very, very good real-world case that tackled this problem and see how it is performing. And then finally, under the hood type of thing, how this actually all works in the background. So let's start. So a lot of people, when we're talking about blockchain development or how we tackle things, we talk about what happens after we send something on chain. So is there an exploit going to happen? How do we listen for events, and a bunch of these different things. But there's actually a lot of things that need to happen before we even send the transaction. I'm not talking about the user signing a transaction. I'm not talking about, for example, I don't know, connecting multiple wallets. I'm talking what a developer team can basically do to alleviate future anxiousness of their users. So we can look at 3 distinct categories. There's actually much more, but the projector is just as big, so we're going to talk about 3 only. So the first one is generally trying to make smart contract development easier, more accessible, and more secure. So here come your audits, here come your educational material for developers, here come Foundries, Hardcats, Truffles of the world. Here comes all of the formal verification things that you can use to make things safer. It's also very important, I think, to lower the barrier of entry for this particular thing, because I think blockchain is still perceived as a very, very complex topic. The second thing is, and I think this is being tackled the most out of these 3, is educating users about this brave new world. So what's a mnemonic, how to send transactions, how can you lose funds, and all of these different things. And then the third one that we will do, which I'll read very quickly to make you more anxious, is helping developers as well as retail users know what will happen before writing something into a ledger that will be until the end of time. I didn't practice this well. But yeah, but let's remember, when you send something on chain, it's there forever. So the third one is actually simulations, and we're going to talk about that a bit more. But let's start with the story why Web2 is crap and a real-world thing that happened like 6 days ago. So I'm from Serbia. We have a currency called the Serbian dinar, which wasn't the most stable thing in its history. One of the sponsored packages actually at ETH Berlin is called the Serbian dinar. For example, a beer during the 90s costed like 5-6 million or even more Serbian dinars. So anyway, 6 days ago, I was trying to make a purchase of around $1,400. I went to my bank's app to see the currency exchange ratio, and in general, $1 is 160 dinars. So we are pegged to the euro, so the dollar is kind of doing this. But anywho, so I thought, OK, sure, I can do this over my credit card, expense it. I'm not going to exchange the money will be exchanged by itself. So I swiped my credit card, and the bill should have been 162K dinars, more or less. But when the statement came in, it was 170K Serbian dinars. So if you look at it, the slippage I got from my bank was around $70 lost. So what happened here is the bank is a very good friend of mine, where when I was signing the terms of service says, if I by hand exchange money, then I will get the better currency ratio. But what actually happened here, because the money was converted automatically, I just didn't click a button in the app, I basically lost $70 because instead of 160 dinars, the currency exchange ratio, for some reason, was $122. And the worst thing is, I accepted this like six years ago when I was opening the account. Of course, I didn't read the papers. There was like dozens and dozens of them. So how can Web3 actually be better in this situation than Web2? So again, what can happen before the transaction happened? So again, same inflationary currency we're talking about, same purchase, same currency exchange ratio. Only now, when I'm submitting the transaction, my wallet should tell me, hey, just so you know, this will cost 170K Serbian dinars. So what can we imagine here that in Web3 in general, this would, I don't know, go through Uniswap, CowSwap, or whatever, and I would know, hey, this is actually $70 more than what I actually expected it to be. And basically, the profit is me not doing the purchase, doing the currency exchange, and then doing the purchase. Anywho, the consequences of not doing things before, checking things before the transaction even happens are manifold. One example is the 1.7 million OpenSea phishing scam, where people thought they were buying NFTs, they were actually sending their NFTs. There's a bunch of DNS hijacking, so basically people opening a UI, and the smart contract addresses are actually different, so people sign something to a malicious contract. Blind multi-signing, we're going to talk about this a bit more. And then maybe something, just like Martin mentioned, the social aspect of it, how we don't talk about all of these things. There's actually an implicit consequence with this current situation, where basically people from outside of this space, and I especially see this while we're doing hiring for Web2 developers to come into Web3, they see crypto, they see the scams, they think crypto is crap, that everything is a Ponzi scheme. Then they don't even look at the tech, which will actually get them excited. They don't get into the space, and we're having problems getting people into the space. So, hi everyone, my name is Bogdan Habic, as the MC mentioned. I come from Tenderly, which is a company that makes a developer platform with a bunch of different tools and services. I'm not going to bore you to death with that particular thing. We have a booth, and we can bore you to death over there. And now let's talk about the solution of one of the problems. So the goal of this presentation, and then if we extrapolate it like 15 years into the future, is to have safe and transparent transacting be a basic human right. So just like the access to the internet, access to monetary things should be a basic human right, it's very important to know, with the amount of transactions that we're doing, what's happening. So this goal is much larger than a single company, much larger than a single product. And in general, I think democratizing this data is why a lot of people actually came into this space. 3 years ago, something like that, on DappCon in ETH Berlin 1, or 4 years ago, time doesn't make sense anymore, but we actually came to the hackathon, complete newcomers to the Web3 space. The first Tenderly feature actually started on ETH Berlin 1. There was 2 additional features built out on ETH Berlin 2, and we came into the space due to this fact, and we should really, really propagate this, and more good people will come. So the goal is, in general, given a transaction input, tell me what will happen. So which events will be emitted, how will the state change, and which functions will be called. So everything before the transactions. And to achieve this, we need a couple of things. We're going to break this down a bit more. So we would need a full archival node, custom state management, and custom execution. So let's look first at a case study in the real world. So a lot of you stood up when I said, are you a signer on a multisig? So in general, but for people who maybe might not know what's a multisig, it's basically a smart contract abstraction for a wallet, and multiple people need to say, I'm OK with this thing for it to actually be sent on chain. Extremely high level. So there's a lot of moving parts and a lot of things that can go wrong here. Multiple people need to sign the transaction for it to actually happen, so human error. They usually do more than one thing in a single transaction. For example, Aave DAO or Uniswap DAO, when they're changing things, they use around, like, I think 2 million gas or something like that, have hundreds of contract interactions for the whole thing to actually work. There's usually a lot of funds being locked in these accounts. So again, a lot of money can be lost. And the last thing is, if the developer team needs to react to an exploit or something similar, it's usually time sensitive, you don't have enough time, and you basically need to react instantly, and then, again, human error and mistakes are made. So let's actually look at the use case of Gnosis Safe. So I think it would be very strange to pitch Gnosis Safe in DappCon, and I would do a much worse job than Martin and his team. But in general, the most used multisig in the world, definitely suggest trying it out. So they have something called a transaction builder. So if we go back to the multi-sig thing that I mentioned, you can do multiple things in a single transaction because these interactions are complex. So what I can do here is I can say, OK, let's do a new transaction. I can input the smart contract address and then the function that I want to get called on that particular smart contract. The thing here is that I can chain multiples of these together. So instead of, I don't know, just doing a Uniswap swap or cow swap swap, one thing I can do is, I don't know, do the swap, send the money to people in my company, then put some money into the Gitcoin grants program and pay out, I don't know, a contractor. So I can do 6, 7 things that can touch dozens and dozens or even hundreds of smart contracts just by using the UI and everything else. So the problem here was that people were blindly signing transactions. So what does this actually mean? I run a developer team. We need to push something out into production quickly. It's like 2 a.m. I wake up my team. I make the transaction, do the fix, and I tell the team, hey, guys, we need at least 5 people to OK this for me to publish it to the chain. I wake up the team. They look at it. Eyes are all grumpy. They cannot even look at the screen. And they have no apparent way to actually check what will this transaction do. So what they do is they blindly sign and trust me that it will do what it is actually supposed to do. So what GnosiSafe, they actually came up with the idea. It wasn't ours, was to add the simulate button in the UI. So when I click simulate, we can actually see that this particular transaction would fail. Now, this isn't Rinkaby, but when I was calculating the gas costs, if I was going to send this to the Ethereum mainnet, it was going to be around $80 to execute this particular transaction. So it says, the transaction will probably fail. Are you sure you want to actually send it? And then the next step is I can actually go into Tenderly here and see where it actually failed. So what you expect basically from a developer tool in 2004. But the thing here is that I can see what will happen and what would have gone wrong. An additional thing, if everything was going to get right, a thing I can do is basically see all of the things, how the state of the chain will change, what events will be emitted, and we're going to see a bit of that afterwards. Again, if I'm a developer, need to debug some of these things, even though something didn't happen on-chain with all of the on-chain data, basically we have access to all of the tools to get this right. So the benefits here that GnosiSafe, not GnosiSafe, but GnosiSafe users got was that every signer knows what they're signing. It's just a click of a button. You instantly see what will actually happen. Don't spend money on failed transactions. You can see it's a pet peeve of mine. I went to a website that checks how much the failed transaction costed you. It was abysmal. See if the complex smart contract interactions do what they're actually supposed to do. So again, a failed transaction is actually much better than a successful transaction screwing things up. Because again, we have written something to the ledger forever, and we need to then somehow fix it. Usually it cannot be done. And then finally, because these multi-sig transactions usually lay low in the multi-sig until everyone signs them, it can sometimes take a couple of days to get all of the signers together. You can know that the transaction 5, 6 days out will actually do the same thing because the last signer, before signing off the final part of the transaction, can actually check and see what will happen. So how was this actually achieved? So what was needed to be done basically to do this particular thing? So if you remember in our use case of me waking up developers, we needed 5 out of, let's say, for example, 8 people to sign the transaction for it to be sent on chain. Now, the thing there is, if we want to simulate something, do I need to simulate all 5 signers signing the transaction and all of these things? We could have actually done it much smarter, and this is how the GnosiSafe team did it. So the first thing is we can impersonate the signer. So we actually don't have to check the signature when they're signing something. We just need to know who the signer is. We need to provide, of course, the transaction input data, so what we're sending on chain. We need to lower the number of signatures needed. So again, in our case, 5 out of 8 signers were needed to actually send out the transaction. What the GnosiSafe team did basically was lower that number to 1. So when they're simulating the transaction, we know that the transaction will instantly be sent on chain. And then finally, we combine all of this data with the current state of the chain to actually see what will happen if we send this transaction out right now. So how does this work actually under the hood? So this is the Tenderly simulator. At this point, I am shilling a bit, but we're going to talk about how you can build this yourself. But basically, here is a simple DAI transfer I wanted to do. So up top, you can see the smart contract. You can see my address cut a bit so I don't dox myself, although I'm doxed at this point, I'm quite sure. And then finally, the amount of DAI I want to send. and then who is sending the transaction. Now, this particular address has no DAI at all, but I want to simulate what would happen if I had enough DAI. So again, the same feature that was used by the Gnosis Safe team to lower the number of signers, basically we're using it here. So we can say, hey, on the DAI smart contract, do a storage override. So in the balances off mapping, I can actually say, hey, my particular account has this amount of DAI. So at this point, we're lying to the Ethereum virtual machine that something is true even though it's not. This will make more sense at a later slide. And here we actually see a successful transaction with the actual asset transfer happening over there. So if the multi-sig transaction that I showed you, which failed, would have succeeded, we would have seen all of the asset transfers, all of the swaps, and everything else over there in place, and we could reason about what will happen. So what is needed actually for you to build this yourself? It's a lot of work, but it can be done. So the first thing is you would need a custom EVM. So you basically need an implementation of the Ethereum virtual machine that you can instrument yourself. Tenderly actually 4 years ago started as a Geth fork on ETH Berlin hackathon, or 3 years ago. Again, I don't remember correctly. But what we started doing back then is just committing code directly into the Geth node, I mean our own version of it, and changing things and emitting data from the virtual machine so we can hook into it and see how it works. Now, it works quite differently. 4 years is a very long time in this space. You need custom state management. So what does this actually mean? So the first thing is you need a full archival node because you need access to all of the data on chain for you to switch it, all of the balances or whatever other crazy thing you want to do with storage. That's the first one. And then also you need a way to basically do a state override. So why do you need a custom state management solution other than pulling the data from the node? You somehow need to lie to your own custom virtual machine something is true on chain, even if it's not. The third part over here is basically custom execution. So a user provides you the input. You take the state from the chain. You take the change state that the user basically told you or you want to change. You need to merge those two, run it through your virtual machine. And then if you remember adding a lot of emits and everything else in the virtual machine itself, we need to return the data. And the data that we saw people find very useful is events that are emitted, all of the state changes that happen because sometimes events aren't enough to reason about, all of the function calls, contract calls. There's actually a very nice project being made right now which before you sign a transaction in MetaMask, it pops up a pop-up, simulates the transaction, and tells you all of the asset transfers that are going to happen. So, hey, did you know that in this transaction, you're actually selling your NFT? You're not buying a new one. Hey, did you know that in this transaction, the swap will actually have a very, very bad exchange ratio because you set your slippage to like 45% for some reason? And then finally, the gas information, because again, sometimes some multi-sig transactions or other transactions use up a lot of gas, sometimes even more than a full block. That's one, setting the correct gas limit and knowing how much the thing will cost in advance. And you can basically do much more when you do simulations. This is what we have at Tenderly when it comes to simulations. So the first thing is it has API access. You can hammer the API with any amount of simulations that you want to do. A lot of teams actually use it as a staging or a forking environment because when you can chain multiple simulations together, you basically get something like a cloud fork. So for example, if I'm a UI engineer, I can just run a fork of mainnet at a particular block, transact over there. I know it sounds like a local node, but it's different because there's a bunch of ergonomics around it. That's one part. And the second part, if my transaction fails for some reason, I can send my fork in the cloud that lives in the cloud. I can send it to a backend engineer or a smart contract engineer to help me debug the actual issue. Integration testing is another one that's a very interesting use case. Basically, run all of your tests with production data. So it's like Andre was talking about testing in production. This is testing in production without making a lot of mess on Twitter, basically. And then you can also, if you make your EVM custom enough, you can do historical bug fixes. So let's say, for example, I found a bug. I needed 1 month to develop the fix. A thing I can do is I can actually go 1 month back in time, change the source code of that particular smart contract, and see if my bug fix would have prevented the bug happening in the first place. Anywho, as I'm running out of time, I want to invite you on the day of the merge to a war room. It's a CTF knives out thing that we're building. There's going to be a bunch of smart contracts that people are going to try to exploit for money. You can learn more about it at our booth. We actually didn't initially plan it to happen during the merge, but again, as the chaos there's a bunch of random events happening during the war room. I think a bunch of things breaking as well, because the merge is happening is just going to add to the stress and to the whole simulation of how a war room scenario looks. And thank you so much.